Hi everyone, I'm excited to start a new project to develop an OpenRC car for the 2022 F1 regulations. We'll be starting with the front wing. I started off by setting up a canvas in Fusion 360 using images from the F1 website. Once that was done, I sketched out the front profile of the base and winglets, as the winglets were angled inward and I wasn't sure of how to get that tilt. After extruding this sketch, I then sketched out the profile of the winglet and cut it from the side of the extrusion. I then cut the shape of the base plate using sketches, added a fillet to create the blended end plate appearance, and added a little flow device to the end plate. It was at this point that I started to follow the canvas maybe a bit too closely, and you'll see why later. Anyway, I cleaned up some artifacts from all the cutting and sketched and extruded the nose and cut it at an incline according to the canvas. I then offset a plane and placed it above the base, which would be used to form the first wing element. I repeated this twice for a total of 3 elements and created a first iteration. I stopped work for a while due to being busy with university work, and when I got back to it a month or so later, I realized that the printing would be a pain with this design due to the inclined surfaces and overhangs that would need lots of support. So I went to patch up these gaps with fresh extrusions, but I was starting to realize that may not be enough to correct the issues with the model. The final straw came when I decided to add an interface to the front of the car, and I just couldn't figure out a way to add it cleanly. It is infuriating to work with, and after 40 minutes of trying, I decided to scrap the file and start afresh from where I built the canvas. For this attempt, the major change to my workflow was to go with the path with least detours and cleanups, and in general just a much easier to understand workflow. I also accepted that there was a lot for me to learn in the long run from this, and decided to open up to using more fusion features than just the extrude and sketch tools which I was familiar with. I started with the nose this time, sketching and extruding a basic shape from the side view. I then added the base of the wing from the top view, which would give a flat bottom, ideal for printing. Then I duplicated and offset the base plate to create rudimentary wing elements. These were then cut according to the top canvas to avoid colliding with the front wheels. I then sketched out and extruded the end plate from the side view. After offsetting it to match with the wing elements, I joined the end plate to the wing elements and cleaned up some minor artifacts, which was a lot easier to do this time due to the flat nature of the bodies. After adding some fillets to the wing interfaces, I cut the nose according to the top canvas and then filleted it to give it a smooth look. After adding some stopgap bodies to join the wing elements to the nose, I mirrored the design so I'd have a checkpoint before which any edits will be applied symmetrically to both sides. I really liked the look of what I had so far, as it was much cleaner than my last attempt and took considerably less time to create. I added a cutout to interface with the chassis, along with a hole for an M3 bolt to be screwed into. If you're wondering, this is to ensure reverse compatibility with the original OpenRC F1 chassis, and my aim is to make this an iterative improvement which won't need reprinting of the chassis, motor and axle assembly and suspension. I'll also be designing a customer chassis later on with some personal touches like trying to take more advantage of the ground effect phenomenon like the real deal. After another cleanup to remove some minor defects, I created an extrusion from the top element to the bottom. This was an attempt to make the wing supportless by connecting overhanging parts to the main body and thus reducing the support requirement. To do this, I cut a section out of this new extrusion which was offset from the top surface of the joined wing to give a shell of the wing on top. However, the test print of this version had the top element snap off and the support usage was still quite high. It later turned out that the top element was far too thin and welded to the support. To solve this, I made the top element thicker by modifying the way I cut the solid wing earlier. That, however, caused holes to form in the middle element when printed. At this point, I was starting to run out of patience with the supportless idea, mainly due to the fact that, ironically, it was taking a lot of support to give even mediocre results. This was partially due to me using a 0.8mm nozzle at that time for a trial, and as I was too lazy to remove it and a little curious how the prints would turn out, I printed it at 0.48mm layer heights, which is massive for an FDM printer. However, I then had an idea. I created a copy of the file and reverted to before I made the wings supportless. I made a few modifications, mostly just making the elements thinner. This was then printed vertically so that only the bottom of the elements was supported, along with a thin strip to support the chassis interface. I also tried to make the top surface curved to make it look interesting. And success! Sort of. It turned out printing in this orientation took far less support, and it also printed the M3 bolt holes cleanly, which was a massive pain in the previous version. The supports did weld themselves to the model, but it is intentional as I had swapped out the 0.8mm nozzle for 0.6 and was still dialing in the profile. This print was a sort of test dummy, as I knew it most likely would need more changes to be acceptable. And it did need some changes. I flattened the curved backside of the end plates, as it caused blobs to form while printing the pointy bottom, which interfered with the rest of the print. I also removed those dents in the front wing and instead went with the loft tool. To use this, I cut each element into 5 segments, hid a couple of the longer ones, offset and rotated the remaining sections, and then lofted between their cross sections. The profile that came from this was frankly amazing to see the first time, and I was super happy that I discovered how to use this tool online. I owe the Fusion community for having so many tutorials to look up whenever I had a doubt, so big thanks to you guys and keep posting. Anyway, after playing with the loft tool for a bit, which included making the elements even thinner so they didn't fuse with each other when lofted, and adjusting the loft angle to give the elements a visible but easy to print curve, I printed this version and it looked great, and after dialing in the slicer settings, the supports came off with a bit of persuasion. I'm sure with better support settings, this will be easy to print and process. I then fitted it onto a spare OpenRC chassis I had left over from when I built my own OpenRC F1, and it fit exactly as planned, and I gotta say, it looks neat. I can't wait to see the whole car completed, and finally getting this done has spurred me on to make the rest of the components. So that's it for now. I've got more elements coming, and hopefully we'll have a video covering the rear wing design sometime next week. Be sure to like, subscribe, and follow my social media to stay updated on this project.